Okay, so today's the day. We're finally gonna do it. We're doing the video on flashing this microcontroller. I've successfully written 4 or 5 of them now. I'm pretty comfortable with the right technique, even though there's still some weird stuff going on. But it programs relatively reliably, so I'm comfortable doing the video now. Huge thank you to Jeff. He sent me all of these odometer zeros, which really let me get this done because I would never have figured this programming out with just the 1 or 2 clusters that I have because yeah, it doesn't work the first time every time, and I was getting really frustrated and didn't want to brick one of mine. So yeah, I was really thankful for these. So again, huge thank you to Jeff. This never would have happened without him. So if y'all haven't checked out his channel, go check it out. If I remember, I'll put a link in the description to his channel. But I'm sure most of y'all know him. I mean, a ton of y'all came here from his channel when he gave me a shout out. But yeah, definitely. Thank you to Jeff. Also, thank you to Mike. He's been emailing me. He actually mailed me this guy right here, which is a Trailblazer one, and we'll play with this. I haven't played with it yet, but we will get to it in this video. It has the Infineon 9397364 on it. I've heard that these will work on the Silverado clusters before, so that's what we're going to try out here, is put the Silverado flash on it, put it onto a Silverado cluster and see what happens, see if it works. It's funny, these were designed in 1998, which was before Infineon actually spun off and became its own company. I think it was 2000. It was either 99 or 2000 when Infineon spun off of the Siemens Corporation in Germany and became their own company. So this one actually says Infineon and Siemens on it. It says Siemens 98. So I think that's the only reason why there's a different part number on there. Is it's just before the spinoff. But I really don't know. So we'll try it out and see what happens in this video. Like I said, y'all be learning with me on that. And don't worry, I haven't forgotten about the 2005 to 2007 boards. This one's a 2005. You can tell by it having a VFD, but having the voltage regulator, which is a different microcontroller. That is the Infineon 21002558. This one is a C166V2 core that's in here. So these support JTAG. You need a special JTAG tool. I don't see the rest of it. I see the cable that goes to it. It's called a mini wiggler. They're made by Infineon. That it should be able to program it, but I haven't made that kind of progress with it at all. These U-Links also should be able to do it, but you need a special license with them to do it, and I'm not going to pay the thousands of dollars for that license, so this is junk, I guess. um, yeah, so that's kind of what's going on with all these different projects here. Let's get into the video and start doing one of these. We'll start with this one. This one was one of the ones. It's not super reliable to program, so we'll show how to get around that, and then we'll go to one. There's another one that programs really easy. I think this one's also the one that I programmed it when it boots up. The screen, it's got steering wheel controls, but it's not in the truck, so it normally would say unknown driver. I changed it and it says unknown fucker on it instead. Just, I don't know. I couldn't think of anything better to have it say. The Mike had already done that to the Trailblazer, where it says unknown racer on it, and so I couldn't copy them. I couldn't do unknown racer on here too, so I had to come up with something else. And I'm not too creative, so I just went with some foul language on there. I don't know. So yeah, let's get into this. Let's take a look at it. You can see this boot up, and we'll talk about the operating system a little bit in this video. It's going to be a really long video, I'm sure. I mean, this is literally me beginning recording. I haven't recorded anything else yet. I haven't started editing, but I am 100% sure that this will probably be a 30-40 minute long video at this point, but we'll see at the end. But yeah, I got a lot to cover, and I'll try to cover it fast. But yeah, let's get right before we get too far into this, let's begin with what do we need to be able to program one of these. You really only need two pieces of hardware and one tool, I guess, and then the software. So tool, you need a soldering iron, something you can solder with, and preferably a little bit of flux to help with that. And you're going to need, for hardware, you need a serial port on your computer or one of these serial adapters. So I'm just using an FTDI 232RL as my adapter, and we only need these three wires, ground, TX, and RX. And then your second piece of hardware is obvious. You need the instrument cluster itself. I wouldn't recommend doing this in the vehicle. I mean, I guess you could drag a laptop out there and power it up in the vehicle and do it, but I'd recommend getting one of these plugs out of something at like a junkyard, or buying the parts for the plug and just making it yourself. So that way you can power it up outside of the vehicle to do this. I haven't tested programming it in the vehicle. I don't know if this little transceiver here sends a interrupt signal to it, which I'd imagine the transceiver probably does have an interrupt, and I don't know if that will affect it while it's programming. So that really covers what you have to do it. Another tool that you're gonna need, and we'll get into why, but you may not need, but if you're doing a lot of them, you're definitely gonna need, is a hot air station. The reason why is, and I'll really get into some detail on it, because I believe this is one of the boards I have to do it to anyways. Sometimes there's something going on here that they're hard to program. Sometimes it won't program. You heat up the area around the chip, and you heat up the chip a little bit, and it'll let you program it. You don't get it crazy hot. You just it. I haven't taken a thermometer and checked exactly what temperature I'm getting it to check. I'd have to guess around 80 or 90 Celsius, so pretty hot. You wouldn't want to keep your finger on it, but not hot enough to really damage the chip. So I'm setting my hot air station to 160 Celsius and kind of holding it pretty far away, and just kind of giving it like while I'm programming it, when it's having that problem, I first just heat up the chip, and I heat up the oscillator a little bit, and then I'll just kind of float around the board with it and kind of come back every so often, just to keep it warm. And yeah, I'll get into some detail on that later. But let's wire this thing up. I know I covered how to wire it up before, but you may not have seen that previous video, and that was when I was asking for help. Now everything's figured out, so I will wire it up for you real quick, and just show you. So let me turn this on. Before I wire it up, because once I wire it up, it just goes into Bootstrap Loader every time you plug it in. So let me just show you. This one is the one with the custom ROM on it, so I'll show you it booting up. So let me power up the power supply, and there you go. So it says unknown fucker instead of unknown driver, like it's supposed to. So yeah, there's no checksums on there, so you can play with the operating system. Still says odometer 0 because there's no EEPROM on there at all. But yeah, let's get into this and do some programming. So I'll power it off here. Okay, so I'll zoom this in and explain it now. So we have two pins. It was, if I remember them off the top of my head, it's like 80 and 89, or 86 and 89. I can't remember what pins exactly are on here for it, but that's these two right here. Are there 5-volt lines that go to it? You need to pull it down to ground to get into the BSL. So those are two pins. It's like POL4. Oh shoot! I gotta find my notes. I can't remember what the other pin name is either off the top of my head. But yeah, pull those two pins down low on there, and that puts it into reset. Then you need your TX and RX. So we're going the TX from the microcontroller, which would be RX on your adapter, would be this purple one, and the blue one right here. It's going to the RX for the microcontroller, which is the TX on your adapter. Which that, if hopefully you can see exactly which resistor they're going to. It'd be this resistor right here, and then this other resistor down bottom here are the two of them. And if you, I caught one of these. I dropped the whole thing and I caught it by the adapter, and it ripped the pads off of the TX over here, or the RX. Sorry, this is the RX. Right? No. Purple's the TX for the microcontroller, so RX for the receiver. Um, I ripped that off on accident. It ripped the trace there. I was able to still program it. I moved over to there's a VIA that I was able to attach to, and that's actually how the microcontroller talks to the VFD driver, is over a serial communication. So I lost this screen for until I fixed it. I just ran a jumper and fixed it. But yeah, just something to be aware of. If you rip the trace on either of those two, you'll lose your VFD driver, and then so you'll lose the screen temporarily. But that's just don't drop it and catch it by the adapter, and you won't have any problems there. So the next thing to go over is just which pins are which on here. If you've never used one of these adapters, this is your first time using it, they should be printed on the silk screen. It's kind of hard to see. I didn't notice it when I first bought them the first time I used one. But yes, it is printed on the silk screen right there. But it's RX, TX, and ground on my particular one. You may get one that's laid out different. There's a ton of different ones of these clones that come out of China, these and stuff that are like you can get these things for $2 to $10 on Amazon, Banggood, AliExpress, eBay, all day long. They're good to have a couple of them. You never know what you're going to need them for or use them for. So I always have at least a few of these around anyways. I think it's a good tool to keep around because computers just don't have serial ports anymore. So let's power this up just like this without hooking it up to the computer, so that way you can see what happens. You'll see it go into Bootstrap Loader instead of powering all the way up. So sometimes you'll get junk on these two screens, but that's just from the delay of it going into Bootstrap Loader. But other than that, you won't get the activity out of any of these LEDs or anything, and a lot of times you don't get anything. So yep, there you go. It's in Bootstrap Loader now, and no real activity, which is a good sign. This is how it should be. So let's go take a look at it in the software, which is going to be Minimon is the software. We'll connect to it. And okay, so let's take a look at Minimon on the computer here. Ignore all this junk that I've managed to pick up. That was me messing with the ground, and for some reason it seemed to pick up some noise on there while I'm recording. So the camera is over my USB on here. The way I capture it, I use a HDMI capture over USB. Seems to, for some reason, pick that up on the COM port a little bit. No clue why. Hasn't affected programming it though. I don't know. Can't answer that question. It's a mystery. But let's focus in on what's going on here. What's important. So let's go to settings, interface. So that's first thing we gotta do is set up our interface. Whatever COM port this shows up on. Sometimes you have to go to device manager to see it. And then just put it on the correct COM port. Baud rate, the maximum baud rate you can run on this microcontroller with this crystal oscillator is 9600. It is auto baud though, so you can use the slower baud rates if you choose to. I haven't found that to make it any more stable. earlier I was saying that this is one of the ones that had difficulty programming, but now I remember I put an X on, and it has the X on it, on the one that programmed just fine. So shouldn't have any issues. I shouldn't need the hot air station to program this one. So I'll find one of the other ones that actually did have problems. That way I can show it to you, programming it. But okay, so that is our settings for that. Now we need to go to the target configurations. Any of these should work. Any of the 16Fs, the C161 and ends in 16F should work. I'm not going to change it though. I'm going with JI with 4.19 megahertz, and you need this syscon enabled. So when it initializes, just initialize syscon 400. Program flash. This is the important one. Main thing you got to do here is remove the activate, and so because by default it has an activate there, just click remove on it and make sure you're using this driver, the C161 XX32CD. If you saw my last video, I was trying to use the JI one. The JI one would crash and you'd have to reboot the processor every single time. So yeah, that was painful. This driver actually does work correctly. We don't have to do that. It's funny because this is the first driver I tried because it's the default one, but I don't believe I tried removing the activate back then. Or it was just I was using one of these ones that was just unreliable. So I got to searching and trying the other drivers, and that was that. I went down a rabbit hole, but yeah, I could have been done with this in January of 2020 had I focused in on the correct driver and wiring it up right. Well, I guess I wouldn't have been able to finish it in January because back in January I wasn't wiring these up right, so I couldn't even get it into BSL. It was August, so I could have been done in August of this year had I focused on the right driver. I spent a lot of time chasing the wrong driver. So that's okay there. You should write down these sections here just to make your life easier later. Because when you program them by section, and it's not like program section 1. You actually have to pick the addresses for it. You can erase by sections, but you can't click the program by section. It's okay. Let's just connect to it and see what we get. I gotta give it power first. Alright, and connect. So you can also hit Control T to connect, or the red C, or just go to target and connect. Those are your options there. Alright, so now we're connected to it. It initialized the syscon on it, so now we actually can't program it. But let's first just read a section of it out. I will fast forward through it actually reading because it's kind of slow. But to do it, you just go add selection, and we'll just read. We'll read the second section. So 4,000 to 5 FFF. All right. So let's just go ahead and read that out. So that's this button. It'll just read the memory. Okay, so we successfully read from it, so we know we have everything wired up correctly. I mean, we already do that because it reset, but there we go. So now we've read out a section of it, and you just have to, when you read it, you don't have to do like programming though. When you read it, you could do 000 to 7FFF, and then read from 1800 to 2FFFF. If you try to read the section in between the two of them, that's a protected area there, and it will just do a SRST, so a software reset, and it'll try to boot up from there if you hit one of those protected areas, and then you gotta start over. So that's why you gotta split it into two different sections when you're reading it. But let's go ahead and load a binary file. You can do either Intel hex or binary. I actually prefer the Intel hexes, but this one I just have in binary right now. So this one, again, it had the profanity in it, which is this one right here, steering wheel controls edit. So let's go ahead and get the profanity off of it. So we load that up. We're going to clear all selections, add selection. We're going to select that same area there. because this is the area that it's different. So let's just do a comparison so we can see that and see what happens when we do a comparison. So I'll fast forward again. Okay, so we can see that the comparison worked, and it turns it black once it's compared it, except for the area that it deemed to be wrong. So there we go. That is it. So let's go ahead and program this, and we'll get it back to saying unknown driver instead of unknown profanity. So program. So first it erases the sector, and then it starts programming it. I'll fast forward from here. Okay, so it successfully programmed it. So let's do a SRST so that way you can see it. So just underscore SRST does a software reset on it. And there we go. It now says unknown driver instead. So that worked. Whenever you do the software reset, you have to physically reset it again to connect to it. So to reconnect, just power it off, power it back on. That's just junk that was still in the memory there. It's not actually powered on correctly. You can tell because the LEDs didn't come on and the screen didn't come on. That was just stuff that was still, it didn't power it down long enough. Capacitance, it didn't lose the memory. I don't know. That's my guess. I don't know why it doesn't lose the memory all the time, but there we go. So let's reconnect to it. So just connect button again. And there we go. So that's all there is to doing it. For erasing a section, if you just want to erase for some reason, you just click erase and then pick what section of it you want to erase. I kind of wish the program worked this way where you just clicked through them. But yeah, to program the whole thing, you have to do each one of those sections one at a time. So we just programmed right here because that was the only part that was different, and I just already knew that. But if you were to do it in the future and you're trying to make a change to one of these, read the whole thing out and see if there's any differences instead of just the one section like I did. So that wraps up using this board. We will swap over to one of the problematic ones just so I can show you programming on it real quick. And then, and I'm not going to record all of it, just get it put together and just do that. And then we will try this Trailblazer microcontroller on one of these. We'll see what happens. Okay, so this is the new board. This one's one that, if my memory is correct, gave me a lot of problems programming, and I know it's the one that none of these LEDs are working on. I think it's a little chip hiding underneath there. I did reflow those. I did not check traces on this, though. So this one's also going to be my test subject to putting the Trailblazer microcontroller on. But let's take a look at what happens when you try to program one of these semi-defective or whatever's going on. I don't know if it's the oscillator, if it's the voltage regulator, or what the deal is, you know, because it does seem to have some voltage issues on these, because sometimes this would come on and you could see it flicker while it was trying to program it. So I don't know if it was a voltage issue going on with the board where the regulator, it's just not, well, not necessarily a voltage, but a current issue where it's just not getting enough current to keep up. Not 100% sure, but let's go ahead and give it a test. So we're going to connect to it. It's already powered up. So connect. And we successfully connected to it. Let's we're going to load one of the Intel hex files this time. We're going to go with non-steering wheel controls. This one currently has steering wheel controls on it. We'll just clear all selection. We'll add selection. I think, I know it's only like 4 bits that are different. I think they are also in that same area we were just editing on the last one, so we'll check that. Alright, 4025 FF. Alright, let's just do a comparison real quick. Okay, so yeah, it was 4 bytes and it was on that same one, so we'll just program that section again and not the whole thing. Let's, without any heat, just see what happens. So click program. Error not successful. Let's go ahead and try again. Not successful. and yeah, programmed 128 and then not successful. And so my first assumption when I started seeing this was, oh god, I damaged, because this was the first one I put a new microcontroller on. I was like, oh god, I damaged the microcontroller running that wrong driver on it over and over and over again. Sorry, before I even ran into this doing that, I programmed one board. It was just a random one out of the pile, and I had no issues. It just programmed right away. So I was like, cool, problem solved. This was the second one I tried, which I put a new microcontroller on. But it was one that I had already tried to use the wrong driver on. I'd used the JI driver on it, and would program it. It didn't work, so I was like, oh god, I damaged it with the wrong driver, because I tried a bunch of times with the wrong driver. And so then I tried another random one, had problems with it too that I knew I hadn't programmed on there. So I was like, okay, there's something going on with the boards then, because this one has a new microcontroller. The other one has an old microcontroller. They're both doing it. So I think it's a problem with the board. I think it's either voltage regulation or clock. I don't know. I really don't know. But they're not stable. So let's go ahead and give it some heat and see what happens. So got it set to 160 Celsius, and we'll just kind of heat up this whole area. So I'm not super close to it, so it's not going to get to that full temperature there. We're just going to get this nice and warm, and then just kind of sneak on out of there with it and try to program it. So clearly we didn't get it quite hot enough. Let's warm it up just a little bit more. And there we go. See it programmed. So just keeping it nice and warm. It's not so hot that it's going to really burn me, but it is uncomfortable to keep my finger there. I'm not going to keep touching it. So yeah, we're getting it warm. Well, we're getting it hot, but not burn your finger hot. It is the science I'm going with. I don't have a FLIR camera to give you an exact temperature. That is on my wish list if anyone wants to buy me one. But yeah, so there we go. That's the fix to these when they're not reliably programming. It's just give them some heat. And again, remember, when you're programming one from blank, you have to program everything. You have to program the whole thing from 000 to 7FFF, and then program from 18,000 to 2FFFF. So those are kind of your two areas. It splits there, but you're going to program all of that on a blank one. On one that you're making changes on, you just have to program the areas that are different. So let's do a software reset on this and take a look and see what happens. So, and there we go. It boots up and it just goes to odometer 0 because there's no EEPROM, and I don't remember if I may have fixed the odometer 0 issue on here. I may not have. I don't remember. But yeah, doesn't have an EEPROM, so it's not going to work anyways. But notice none of those LEDs came on. This board has another issue with it. So let's take all of our wires off of here so that way we can solder on that other chip and see what happens. See if we let the magic smoke out of the chip. And if we do, I'm sorry. If we don't, let's program it and see if it'll work. He did mention that he already programmed it, so I am going to plug it in and just see what's going on with it, but I'll do that off camera. Okay, I know I promised you guys that I was going to take this chip off and put it on the other one, and I will do that, but not in this video. So I already started editing and realized I'm at like 30 minutes already, so I'm going to wrap up the video here. We just kind of showing you that this guy works, and thank you for making it this far into the video, and this will probably be my next video. I do have a nail gun I need to fix, so that could be my next video. And yeah, I have a bunch of projects. I also want to show you guys how I did a little bit of the editing in the program memory on these. Sorry, had a brain fart there. Just how I edit the flash a little bit and put something different in there, some different message on there, so and different things like that. Like I've already mentioned, I don't know assembly language. I don't know how to program that way, so I can't do anything big. Like I really want somebody that does know assembly to program us a uh, flash for, well, not doesn't have to be for the Trailblazers, but I really do want it for the Silverados, where say you have the car in the run position and in park, and you hold the trip reset button down, and it just does a self test. So all the LEDs come on, and all the motors sweep to their extreme and back, and that's it. I really would love somebody to make us a custom ROM that can do some sort of self reset. It doesn't have to be exactly how I said to do it. You figure. You put your spin on it. I'd also love to see a Easter egg to put in here that people would just technicians would randomly find. My idea is to put something funny in the what do you call it, the software version number, so that way when somebody reads the software version to update it with a Tech 2, they see something funny. I think that'd be a good place to hide an Easter egg in here. Yeah, I don't know. Make it software version boobs or something. Make it like 8008. I don't know. It's just my idea. I'll go wrap it up here, though. We're already 30 minutes into a video, so I'll see you guys in the next one. I hope you liked it. This was a ton of work, so if you made it to the end of this video, it's a 30-minute video. Frickin' subscribe, alright? Just shut up, man. Subscribe. Alright, I'll see you guys in the next one.